Okay, so good afternoon, everybody, and welcome to this webinar. My name is Maria Leon, and I'm a research manager at Circularise, and I'll be your host and presenter for this webinar. At Circularise, we are committed to achieving circularity and maximizing resource efficiency, which is why I'm very happy to have you all here today to talk about the circular economy within the toy sector, the challenges around traceability, and the solutions from the EU-funded project PRecycling. So today I will give you a brief overview of the regulatory context that we are setting this project and the toy sector specifically, then context around Circularise and the data traceability tools that we have developed and how we're using them for improving recycling in the PRecycling project, to then proceed with the discussion with our guest speakers. So here we are with different experts from the PRecycling project. I will introduce them before the session that we have. But now I would like to start with a little introduction, a little understanding of the traceability and regulatory part, so that the audience can know a little bit more. So first, I would like to launch a poll about to know a little bit more about the audience, know a little bit more on how much do you know and how much do you experience, how much experience you have with the traceability tools. So please answer the poll so that we can then have a little more understanding of your profile and what you're also here for. Then I'm now going to continue. So first, let's start with our content. So I'm going to first give the word to my colleague Serena Garibaldi, our regulatory aspects experts, and she will present a little overview, as I mentioned, on the regulatory part that we are setting this context and this webinar onto. So Serena, over to you.
Yeah. Thank you, Maria, for the kind introduction, and hello, everyone. My name is Serena Garibaldi, and yes, I'm here today to present the legislative overview of the new toy safety regulation. But before going through the new proposal, let's actually take a step back and assess how is the current toy framework in the EU market and why this new proposal was needed. So, at the moment, toys are regulated under the Directive 2009 on the safety of toys, and as the name suggests, it lays down the safety requirements that toys must meet to be placed in the EU market, whether they're manufactured or not in the EU, so to ensure their free movement in general. And to place toys in the EU, there are currently two possible conformity assessments overall. So either the manufacturer demonstrate compliance by self-verification, and that's using the EU harmonized standards, or the other possibility is to have a third-party verification through a notified body. And what you get in the end is that when you buy a toy online or also in a physical shop, you have the CE marking that shows that the manufacturer's declaration satisfies the essential safety requirement. Now, what was the issue? However, the directive was from 2009. So, of course, the online market situation was very much different from what we have today. And many toys in general in the EU were found as being non-compliant. And in fact, toys made up actually a quarter, so 23% of products that were reported as dangerous in the EU in 2022. And this data was actually further back up by a more recent study that showed that on over 100 unbranded toys that were bought online, 80% failed to actually meet the EU standards. So that's why the need to have this new and improved regulation of toy safety, which in general encompasses stricter rules for toys and, of course, a higher level of harmonization throughout the Union as we go from a directive to a regulation. And to do that, this regulation expands the directive ban on toxic chemicals, so covering new harmful chemical products and hazardous substances that could affect the immune, nervous, or respiratory system of children. To give an example, for toys that are meant for children under the age of 3 or they are intended to be mounted, there is the prohibition to contain any allergenic fragrances, or there is also going to be a stricter limited on the intentional use of PFAS. And something else that characterizes this new regulation is the introduction of the mandatory digital product passport. You see here a bit of a timeline. The regulation is now at its very final stage. It was finally approved in the EU Council a couple of weeks ago. So now we're missing the final vote in the plenary session. If you want to tune in and see the results of the vote directly, it's going to be voted in 20 days. And then what we have is a transitional period of a total of 54 months. So 4.5 years, because before every toys to be sold on EU market will need to come with a digital product passport. Some steps in between, of course, foreseen a transitional period where toys that are actually still complying with the current directive will still have time, of course, to be sold. And in 2028, there will be further information on delegated act and implementing act on more technical aspect of the digital product passport. And in general, for those of you who are maybe not too familiar with the concept of the so-called DPP, in general, it is a secure and transparent digital record of a product life cycle journey. So not only for toys, but also for vehicles and other products, suppliers needed to answer to some specific questions, such as what materials can reduce the carbon footprint, or which part can be easier to disassemble or be recycled, and how does this design, for example, can impact the end of life of a vehicle. And all of this rising also legislative requirements all come together in the concept of the DPP. And with this regulatory framework in mind, I will now give the floor back to Maria.
Thank you very much, Serena, for this overview. Now let's continue with a small introduction to Circularise. So at Circularise, we're committing to achieving circularity, as I mentioned at the beginning, and also maximizing resource efficiency. Here, Circularise is an SME based in the Netherlands, and we have developed a platform for secure data sharing among value chain stakeholders. So we see the importance, after hearing everything that Serena mentioned, of having traceability and having information throughout the entire value chain. However, current means of data gathering involve emails among stakeholders, which can be time-consuming, susceptible to fraud and to security breaches, and there is not yet a solution to this challenge that we have. For setting, for example, also there are like centralized databases. However, these tend to be also outdated, and not all of the companies are always willing to have the information in one place, because again, this is very susceptible to security breaches, and this is something very crucial for them to keep everything under the IP very secure and protected. So here is where Circularise comes, and we provide a tool that enables to securely share sensitive information among value chains. And with this, suppliers can now create digital product passports, the DPPs, and share information to their customers without really endangering their intellectual property, their IP, and their competitive advantage. So information such as sourcing, chemical composition, technical properties, environmental assessments is all now available in one place throughout the value chain for all the stakeholders involved. And so all this data enables to comply with different regulations, standards, certifications, or even specific OEM supplier requirements, or for manufacturing details, or for improving processes themselves. Stakeholders also can now, among the value chain, agree upfront on which questions to ask and which data to trace, so that all the stakeholders are aligned and are aware of what data will be required, and all this also following all the regulations mentioned before and all the really data needs for the processes and for making value chain more circular and sustainable. So in general, the DPPs enable first to perform impact assessments, as well to provide proof for the certifications and the claims around, for example, improvement of sustainability metrics or others. It is important, it is possible also to share data that supports processes improvements and better resource allocations, as more informed decisions can be taken with all the data available for each of the stakeholders. In the end, this also facilitates overall compliance and also risk mitigation and supply chain resiliency, because all the data is available for companies to make better decisions. And then finally, by having data transparency and value chain visibility, new business models can also be developed. For example, with the chemical and material information, end-of-life components can be better recycled, or even have new product designs with extended life cycles. And an example of these developments is the PRecycling project. So the PRecycling project aims to develop an easy-to-use methodology for sorting, sampling, tracing, and recycling plastic waste streams to produce consistently a high-quality, safe-to-use recyclates for 3 industries, so toys, appliance, and textile sectors. However, the proposed methodology in PRecycling could be also adapted for many other sectors, for example, packaging, vehicles, electronics, which really provides a significant societal impact and commercial and industrial interest, because here we're focusing on 3 industries, but again, this could be extended to many more. Then Circularise contributes to this goal, improving traceability and information sharing in the value chains for better and more informed decision-making through the system. So Circularise improves its digital tools to support the requirements for the toys, appliance, and textile sectors, as mentioned before, the ones from the PRecycling project. And these enable stakeholders in these value chains to securely share data throughout the different steps, so that stakeholders downstream have greater visibility into the components, comply with regulations, prove claims such as the recycled content that their products have, and improve their processes by having more information on the different components and the different parts. So for example, end-of-life operators can now know if certain substances and chemicals are present in the components they received, so that they can use the most adequate processes and maximize the efficiency at end of life. OEMs are also able to prove the recycled content of their products, complying with different sustainability claims, and have more transparency of where their products are being sourced and where they are coming from. So in PRecycling, Circularise supported multiple pilots to demonstrate its technology. Here are some of the partners involved. And this included the traceability, as I mentioned, in the toy, the textile, and appliance sector. So in this webinar, we're focusing on the toy sector. And here you can see the traceability of a recycled boat toy produced by AIJU. So here you see a Sankey diagram where companies can click on the different components, and they will have different details on the left-hand side of the platform, on the dashboard, to check on the different details. So for example, they can see some data from the final product, like the recycled content, the type of waste streams, as well as the technologies used, among many other information. And as mentioned before, this data comes directly from each of the companies in the value chain, providing reliable information. And they can also determine who can access each data point, protecting their sensitive information. So not everybody in the value chain needs to avoid any breaches in security. So Circularise doesn't only enable traceability within their platform, within our platform, but also we provide a publicly accessible option. So entities and stakeholders who are not part of the system can also get this required information. So you can scan the QR code that you see in the slide, and this will take you to a public website that contains all the information selected for public disclosure by the partners in the project about the final boat toy created, as well as its different components if you go through the different parts of the value chain. And for example, with this, end-of-life operators can use these QR codes and can know more about their products, so that they can better have their processes. And now we also have a different toy example, because the previous one was about the closed waste stream. So we had from toys to toys, and now this one is from appliance to toys, which also helps to prove where recycled plastic comes from, that they can have multiple journeys, involving the open and closed loops, so that you can also see traceability within different industries. So again, you can scan the QR code. And with this, we see how PRecycling, the project, brings a solution to the lack of traceability and of proofs from recycled claims through Circularise traceability tools. This enables to capture data throughout the different stages and to create a digital product passport with the information, which also supports optimizing end-of-life processes or even manufacturing processes, that also helps companies prove their claims and regulation compliance. Now, given all the background that you have heard, we can now jump into the roundtable discussion with the experts that I'm very excited to present. So from Renewi, we have Ana Rita Neiva, a plastics engineer with a career developed in the recycling sector, carrying out several innovation projects. We have Bernard von Vacano, leading global corporate R&D in polymer recycling at BASF, with deep expertise in material science, design, and circular economy strategies. Luisa Marin, with over 25 years of experience in safety analysis of toys and other consumer products, currently a manager of the chemical safety of consumer goods in AIJU. From Fraunhofer, we have Martin Slumer, who has been since 2015 Deputy Head of the Process Development for Polymer Recycling and Business Unit Manager for Recycling and the Environment at Fraunhofer IBB. And finally, mentioned before already, Serena Garibaldi, coming from the European Parliament and now in the Public Institution Affairs Officers from Circularise. So thank you all for being here. We have, now I want to start with, let's say, the overall positioning of the industry. Maybe let's start with Werner. If you could tell us a little bit more of what are the challenges that BASF has faced towards the progressions into circularity and the use of more recycled materials in terms of data. So because we saw a lot of information of the recycling and the regulations information. So can you tell us a little bit more of the challenges faced so far by BASF?
Yes, absolutely. And first of all, thanks a lot for having us all and sharing some of the learnings and the great results from the project, and really sort of tapping into this field of data as an enabler for circular economy. And this is sort of for us, BASF is a materials manufacturer, right? So we make the polymers, we make compounds that are then used by others to make products, or even components that end up in products. And that could be in the automotive industry, as well as could be toys, or could be other sensitive applications. So we need to guarantee the quality of our products. And that could be for safety reasons, so physical safety, crash relevance, right, in cars, but it could also is, of course, chemical safety, food contact, and so on. So we have quite elaborate quality assurance mechanisms in the typical fossil production chain. But now with recycling, we have much more to think about, because now we have sort of waste-based feedstocks with all the potential uncertainty that comes to it. So we need to know the history of the material. It's not enough to rely on sort of a supplier that has always supplied the same fossil raw material as we're used to. Now we have different sources. Might have changes over time. We really need to dig into the history of the material to be able to assure the quality ourselves. So right, we are in the middle of the whole chain. And then also we need to give our customers certified data together with the product. So we need to communicate much more than before. In the past, it's of course data sheets, technical data, and chemical safety information. But now we need to certify, for example, recycled content. We need to prove that the material that is in our product comes from a waste-based source. It could even be like in some closed loop mandates, we need to prove that it came from toys, or it came from food contact, or it's automotive plastic back to automotive plastic. So you can imagine that could be a huge complexity without the right data management strategies and tools to communicate. And then finally, at end of life, we have some products that really benefit from a design or recycling approach, but that means we need to identify them. We need to find them again when they reach end of life in whatever product they're used, because then we can use the specific approach that we designed them to be used for. So on many levels, I think data is a crucial element to make this all happen.
Yeah, this is very interesting what you're sharing, because indeed you started saying with it's not only one sector, but this is basically all of the different sectors. We're here joined for the toy sector itself
Absolutely,
to show
yes.
the examples, but indeed this is something very crucial for all other sectors. And I think BASF is the example of all of the different sectors that you can have, because you have multiple. So it's really interesting to see that this is not only coming from one direction, but actually multiple ones. And also, yeah, so you're also the beginning of the, or in the middle also of the value chains, but you also see the challenges at the end of life products. And that's also why we have here Ana Rita from Coolrec and Renewi. That maybe, Ana Rita, can you tell us also a little bit more on what are these challenges from the end of life perspective regarding the data and so on?
Yes, sure. Hello, everyone. My name is Ana Neiva, as I was introduced. I work at Renewi, that is a recycling facility. We do mostly mechanical processes. The biggest challenge that we face is the lack of information on the presence of certain substances, I would say. If I can give you an example, certain hazardous substances or legacy additives that may be present, such as brominated flame retardants or phthalates, can pose a risk when present in the final product. And yeah, we need to comply with regulatory limits. So therefore, it can be definitely a big challenge for our industry. Due to the lack of information, more tests are required, which leads to higher costs and also less efficient processes. So without standardized digital data about the product, recyclers rely on physical analysis and experience rather than reliable upstream information. With the variability of the composition of our income waste, the high analytical costs, the low testing frequency, and the representability of the analysis, it's quite low. And this makes things quite difficult, especially if we need to meet EU regulation.
Yeah, so indeed a lot of information for compliance with regulations is needed, but also for the processes themselves, I guess, to make them also, to improve, to have the optimal results out of the recycling. That's also a challenge, I would say, from the end of life. And yeah, as you mentioned, oh, sorry.
Yes, indeed, I was agreeing with you. Please go forward.
Yeah, no, like also the information that you're mentioning, it's let's say details around the composition, but also where is it coming from? Is there any other details also required or very relevant that are not currently there for recyclers to share, to optimize processes, or even to just comply with these regulations?
Yes, so we as recyclers, if we know the composition of our waste, we will be able to recycle better and with higher efficiency, indeed. I can give you an example. Being a mechanical recycling company, we have different processes and we treat electrical and electronic appliances. I think at the end it will be quite similar to the toys, as we discussed before. These appliances can contain very high risk components, such as batteries, and not only due to the risk of fire and explosion, but also because of chemical hazards. And I think that DPP could greatly support recyclers by, for example, identifying the type of battery used, indicating the exact location within the appliance, providing instructions for safe handling and also disassembly, and supplying information on potential reuse options, I would say. All of these elements can significantly improve the recovery of critical raw materials and also help avoiding cross-contaminations. If I can also give an example on refrigerators, we also can mention, for example, compressors, which often contain oil, gases, and regulated substances, such as CFCs or HFCs or hydrocarbons, and the proper identification and guidance through the DPP would be very helpful for recyclers to comply with regulations. So, yeah, this could work, but I think that it's essential that producers keep product information up to date as well. Because if you think about an equipment manufactured 10 years ago, may not contain regulated substances that recyclers should be aware of. So producers need to ensure that this information is regularly reviewed and updated as well.
Yeah, this is a really interesting example, like a lot around the composition, a lot around compliance with regulations. As we know, in Europe, we have a lot of regulations, and there is a lot of push for this compliance and also for the safety of people. As also Serena mentioned it before at the beginning, there is a lot of things that can be, let's say, mentioned. And it's really interesting to see that even from the end of life, as you just mentioned, Anna, that there is a lot of push for complying with regulation, but also, as Bernard mentioned before, that at the beginning of the supply chain, it's also very relevant to check for these substances and for all. So now also I would like to add or to ask for the middle of the value chain from AIJU's perspective. If Luisa, you can tell us a little bit more of what were the expectations from the DPPs or for this traceability? What is important when manufacturing these toys to have into account?
The manufacturers. I think it's necessary to, it is not so straightforward. I don't have a straightforward answer for this, but I think that keeping in mind that by the time that a product reached the recycling facility, the substances that were regulated 10 years ago, if we think about, for example, a refrigerator, that it's easily 10 years in the market, a producer needs to think that by the time that this equipment reaches the recycling facility, the recycler needs to be aware about the presence of substances. And of course, there is no manufacturer that wants to disclose all the information, but if we could create a system, maybe together with, like partnering with AI, we could create the possibility of identifying some, for example, types of equipment. If, for example, the labels or the QR codes are damaged, AI could maybe identify the equipment type, the model, and could provide directly to the recycler which possible substances and in which parts can be present already for the recycler to know where it should tackle to ensure that no possible cross-contamination will happen in their products.
Yes, of course. That's indeed from the end of life perspective how manufacturers can provide this. But now talking more in the PRecycling project, AIJU was in charge of the manufacturing of this toy. So maybe Luisa, you can tell us a little bit more of this perspective, complementing to Ana Rita's answer.
Luisa,
Luisa,
Yeah,
yes.
we can't hear you. No. Now you're muted. I think you're muted now, but
Now?
Yes.
Now, yeah. Oh, sorry. Sorry, it's the a little bottom in the my microphone I put here, and I don't know why I muted myself. Sorry. I was saying that thank you for inviting us to participate in this webinar, and just to add some points to what Ana Rita said, is that the manufacturers expect more clarity about the obligation and responsibilities to include in the digital passport. What data are need to include, how to manage, what tools to use. This is very important because related to the toy safety regulation, the digital passport will replace the declaration of conformity, and the declaration of conformity is a very important document for the toy safety, for demonstrate that the toy is safe and that and is okay to be sold in the market. Again, the manufacturers also expect a reduction of the administrative work in order to simplify the traceability, and also the market surveillance. It's expected that this tool will avoid duplication with other conformity documents, for example, for REACH, because there is, there is a complementarity between the regulation and toys, contains different regulations coming from different aspects. In addition, also the manufacturers request a specific support from the European Commission, let's say as a practical guidelines on something and about how to comply with this obligation. Of course, the passport should be compatible with others digital passport, for example, for batteries, textiles, because the idea is one system, but for multiple uses. They need also help transparency, quality control, and competitiveness. This is they need a practical digitalization of the data, and this will help for the fair market competition. Because it would be easier to identify non-compliant imports and online sellers. But what is important for the recycling is all the data related to sustainability, and especially that data that was mentioned before is related to the not only the recycled content and the type of recycled material and the origin that will provide traceability and transparency, but also the amount and the type of chemicals that are present in the product. And this is quite important because all the obligations and all the reinforcement of the obligation related to the chemical substances in the toys. And of course, the parameters related to recycling and traceability and so on will allow the manufacturers to differentiate environmentally sustainable toys, and of course safe toys in the for the consumers.
Yeah, thank you very much, Luisa, for the great explanation and the input. This is also very related to everything that we've talked a lot about. Basically, push for this data. It's also coming from regulation, from complying with these regulations that are out there to make a more safe product, a more recycled product, a more circular product. And this is, yeah, exactly what you're mentioning, how to comply with this data, with these regulations. And the provision of data is basically the support for having or making sure that this is the case. And yeah, maybe Serena, going back to the regulations, maybe you can tell us a little bit more about how the ESPR is impacting this, and also you gave us already a little bit of an introduction to the regulation, but maybe you can tell us a little bit more now that we are in this topic with partners. If you would like also to complement.
Yeah, so the so-called DSPR, that is the Eco Design for Sustainable Product Regulation, it's the cornerstone, let's say, of the Digital Product Passport. So it is the legislation that introduced the same concept. And the idea, of course, it was to improve indeed, as we already mentioned, the circularity, energy performance, recyclability, and so on of products. So that is why this regulation in general establishes some eco-design requirements, both for specific product groups and also horizontally across groups that has similar characteristics. And indeed, this cover also the resource efficiency. As for the toy safety regulation, whether there is the presence of substances of concern. So you see a lot of alignment between these two regulations, because what the EU is doing at the moment is to take the example of the Digital Product Passport from the ESPR and aligning, let's say, all other passports to the same standards, so that the European Union, let's say, will have a unified DPP concept. So also because we mentioned textile, the Commission in particular, because now the ESPR, let's say, covers the broader range of products and just keep the frameworks. What we're missing now, it's the delegated act that, of course, will specify the rules for each product category. So in April, the EU Commission published the working plan of the ESPR. So we know, for example, that next year there will be the delegated act on iron and steel. In 2027, the one for textiles, tires, and aluminium. And then we will also have furniture and mattresses. And so the same idea we see, of course, in the toy safety. So to have this DPP all aligned, of course, let's say that in the eco aspect, while for the toy safety, it's of course to ensure the safety of children in the EU, but the requirements are very similar, because the idea that there is at the moment is that potentially in the future, every product that is going to be sold on the EU market will need to come with a DPP. And that is, of course, to ensure and to prove what characterizes the European Union, that is the high quality of our product in general. And so, as we've seen in the same PRecycle project, we have every actor of the supply chain that is involved in it. So we have suppliers, we have recyclers, manufacturers, and the DPP service providers working together, sharing data and information, because, of course, without an harmonized data formats, that cannot be a really like exchange of information. And to include all the chemical, mechanical, physical data on various products. We all have this DPP on which to rely on to ensure also that it's fully interoperable indeed within different countries and data spaces.
Yeah, thank you very much, Serena, for this great overview. It's really good to see how we see that there is a push for data coming from regulations, as you mentioned, from different perspectives, so circularity, but also safety, and how important is data for providing such compliance. But we should also talk about what are the challenges for these regulations to come through, or for companies to follow them. So what are the challenges in setting up the DPP regarding, for example, defining the data to be traced and collecting such information? So maybe Martin from Fraunhofer, can you tell us a little bit more of what are these challenges that can be presented? What have you seen so far? What is in the industry so far?
Okay. Now, I'm working for Fraunhofer in the research institute, and I'm dealing with recycling for more than 20 years right now. And from this perspective, I want to say that DPP is not only a digital problem, it's much more also a circularity problem. So whatever, if we talk about any kind of data that we want to collect, we first have to define exactly how to analyze them. If we want to bring in recycled content and bring in the unknown materials, we need harmonized analytical methods and so on, that everybody measures the same and means the same with what they are measuring. Afterwards, it needs to be somehow certified, and then it needs to be well understood. Everything, not a digital problem, but it's so crucial for the data itself to enter this system, to be validated and useful somehow. And the other point is when it comes to the end of life treatment, as far as I have seen most of the mechanical and also chemical, whatever solvent-based recycling systems, it is mostly a bulk system. So bulk material is somehow treated. So it's not an item by item recycling. So if you want to read all the information, which is probably with any QR code or whatever, it's probably not available anymore at that stage. So how to bring in this information, how to read this information, and fast enough that the recycler can even react. If this is not done properly, then the only information is there might be in the bulk some flame retardant, there might be some plasticizers, but this is knowledge they have right now. So it is not a precise one. So here I see the largest challenges to bring all the information which may be collected and gathered somehow to the point of interest to make the correct decision. And if we think in circular systems, after being shredded, being recycled, whatever, we have a new material again. So what is now with the old information? Do we want to trace it back or to bring or to collect it to make something new out of it? Or do we start from scratch again? Saying that, let's say, the smallest part right now in this value chain, which is the recycler, and they are all having economic problems right now, they should now be the ones who have to do the full analytical understanding of what might be in there and transport that as a new part of the raw material in the value chain. So here, this is, doesn't seem to be very fair to me. And the higher the level of information which is then required in the second and third cycle might highly overestimate, let's say, the competence and also the economic power of the small recyclers here. So here we need much more systematic answers how to gather and to assess data, and probably sometimes it's not always measured, but also to have a common understanding what is possible, what are the relevant information, what is probably much too detailed, which will never end up somewhere where it helps.
Martin, but I think one point that is super important that you raised is that the digital twinning of the circle is not enough, right? It will probably also reshape the way the physical side is to be done most efficiently. So I guess with the passport, we really need to do much more on the object level. And that's probably also with the repair and reuse strategies coming before the recycle. It will have to reshape the recycling system, because today shredding and sorting is also a result of not knowing anything about the composition of the object, and then you try to solve it by breaking it down in pieces that you can sort. So I think this will be very interesting to see how the digital evolution and DPPs could reshape also and optimize, ideally, the recycling chain.
I totally agree. So there will be changes, and the information will be somehow relevant, but in the end, recycling is still a physical problem and not only a data problem. And there will be a mix of data, and we need to understand at that level, there will be a mixture of much data. If we want to trace that and to transport, let's say, millions of data to the next batch of recycled material, and do this twice and 4 or 5 times, then I think there will be an overload of data which is not useful anymore. So we also
the good thing
data reduction. That's my point.
Absolutely. The good thing about the digital tracing is you can do that. You can control it because you can reset it. there was a question in the digital Q&A about physical tracers. There, the question is, what happens with them, right? Do they stay in there? Are they removed? And it just as a teaser, the PRecycling project also had a small work package looking at physical traces, but that's probably too much for today. But the digital one has a big advantage, as you say, right? You can redefine and press sort of restart and only convey the relevant information for the next cycle.
Yeah, exactly. And as we're mentioning here, we're exploring how to set these things, because this is an unknown territory that we're trying to figure out what's the best way. And indeed, you can always set when there is a renewal of the information needed. How many cycles is it enough? Is it one? Is it two? And that's where also the beauty of the digital tools comes, that we can fine tune these things so that there is not an overload of data. And indeed, given that we're having now a more digital focus, it's also the fact that this will drive the innovation into the physical also setting of recycling. And that's also very relevant to you mentioning, Martin, and that was also very interesting for you, Bernard, to mention that there would be a change that should be, let's say, made into how recycling is perceived and how to achieve the circularity, because so far there is a push for circularity and the digital tools should accompany it, but also there should be a change, or there should be also a exploration of how this physical tracing should also go, and to better have a understanding of this. But indeed, the challenges of digital product passport is something that we're seeing, and that's why we're doing these projects, to understand better how to make them fit into the context that we have nowadays.
And we need both sides. So the physical recycler needs to understand the digital one. People and the digital organizers of this data also need to understand the physical problems, so that they know what is relevant and what is not relevant. And there's something, probably one point which I missed here, is there might come something in a digital, in a value chain. There might be traces of contaminants which are not coming from the value chain. They're just coming from the recycling process, or from not intentionally added substances from, let's say, from a shredding process, where, let's say, a metal from a shredding device is entering the plastics in the end. This is never traced. And in the end, the digital passport provides you with a safety which is probably not in. So that means, in the end, it is not only what has been collected until the material enters the recycling. So there might be something entering again without having that in mind. And this is exactly why we need to rescale directly after recycling. There need to be new data here to fit in. And this is, for me, it's still the point: who is the one who is responsible for analyzing this material and providing the data in the end, if the recycler itself cannot do the job alone.
Yes, indeed, and that's also what we're trying to see here, how to close the loop, how to not leave the DPPs only for recyclers to be seen, but actually for recyclers to contribute and be the first ones of the second line of the value chains, and how to make this process continuous so that the information is not lost, and how to make them not only a passive actor, but also an active actor, providing these details so that we can for sure have this circularity of data, what you mentioned. But indeed, these are all challenges that we're trying to solve, and that we're trying to understand first, to find the better option to go forward. So that's what also we have seen in the PRecycling project, not only to get to the end of life, but also to start from the end of life, because what we had here were basically end of life components being used for making a recycled toy. So we actually started with Coolrec information with either the recycled toys, or the waste toys or the waste appliances, going back to a new toy being generated with recycled plastic. So this is also something that we're figuring out. And I think, looking at the time, I think we can now move maybe forward with the questions from the audience. But before doing that, I would like to ask the speakers if there is anything else you would like to add at this point to close and to round up the roundtable discussion. from anybody?
I would like to take the opportunity to just say a few more things also to what Martin said. Indeed, it's quite tricky to guarantee that there is no cross-contamination. And that was also one of the reasons why I think we need to mitigate certain hazardous substances at the beginning of the value chain with the identification in an earlier stage. The DPP would provide a lot of information that could support us in a batch to batch and would allow us to not have to analyze with such higher frequency all our materials, which is not economically viable. So I think it's just something that could be in that DPP will need to develop at another level, I would say, because at this moment we are also using DPP at Renewi or Coolrec. We are using DPP from batch to batch. We have a lot of information, but the information that we have, it's added manually. So also how reliable this is, because you have the human error, it's very easy to make a mistake. But I think it's also important to have these discussions and to think how these tools could actually support this in a real scenario. And in my view, should be in an earlier stage when a recycler receives the equipment, does not have any information about this equipment, was produced a lot, some of them a long time ago, and we don't know which type of batteries can contain, which type of gases can contain, and there is where we need to tackle to be able to recycle better and to avoid that cross-contamination that you mentioned. Yeah, thank you.
Thank you very much, Anna, for the input. This is indeed part of the challenges that we're seeing that we have to solve in this, to know where products come from, what are they made of, how to trace the data that is not being provided, and so on. So thank you for mentioning this, and thank you all for the input that you have provided and for being open to have the discussions here so that we know what to face and where should we go and what are the challenges that are out there that need to be taken care of to provide this solution to a circular economy into the different sectors that we have. Maybe just then, is there any other questions, or can we just proceed with maybe 1-2 questions from audience, seeing the time? I think then we can proceed. So for the questions, I see that a lot of them have been solved by the different speakers. So maybe I see one from Rashid to Anna Rita, actually. Anna, yes, I understood that, but that's what I mean. Should the AI, when the QR code is no longer available on the product, rely on tracers, or should it be combined with chemical analysis, or should it just identify the brand so then you can fall back on the producer to retrieve the DPP?
Yeah, so that is dependent on what we can get through a combination of AI with DPP. I think it would be very helpful that if our barcode is broken, if we cannot get access to any information, at least through AI, we could get information on the model, for example, and then we could retrieve to the DPP, as you mentioned. Through, for example, having a online system in which the producers inform about possible substances that some of the models can contain, and create a type of sport. I don't say having chemical analysis, because I think it's quite tricky to combine that with chemical analysis. How reliable that would be, how much time it will take. We are talking about a continuous process. but definitely to find a way of partnering these two things, DPP and AI, I think would be very helpful for the recyclers.
Thank you, Anarita. And then we have one more question from Diana on how will we ensure quality and credibility of data of products coming from outside of the EU?
Yeah, so I can take on this question. Of course, every manufacturer or every actor that is involved in the supply chain is responsible from their own data. Of course, this data will then be verified by authorities that will screen actually the products that enter the EU market. So, for example, regarding specifically the toy safety regulation, it is envisioned a new IT system that will scan the QR codes of toys when entering the EU market. And the same concept kind of applies with other product categories, which is why a core aspect of the DPP is also the interoperability. So that it's making sure that a DPP, so data that comes from different countries, are interoperable with the same system that the union has. So yeah.
Thank you very much, Serena. And looking at the time, I think, yeah, there are many questions now, but I think we should close it. Of course, you can always reach out to Circularise, to all of the different experts if you have any specific questions that you would like us to address. I would like to now thank the speakers for being here, for taking your time to share all your experiences and all the different information from your companies or your perspective, and for being here to discuss all together what are the solutions that we have and for the challenges that we're facing to get a more circular economy, especially focused in the toy sector here, and also for sharing the details on the outcomes from the PRecycling project. So thank you very much for all the speakers for being here. And thank you all for the participants, also for the attendees to be here and to listen to this. We hope that we get into better insights and to better solutions to achieve the circularity that we need for the world to be improving and to comply with all the different regulations and initiatives that we have in Europe. So thank you all for being here. And I wish you all a great rest of the day.
Thank you very much. Bye-bye.
Thank you. Bye.
Thank you. Bye.
Thank you. Bye-bye.